Hello, it's me again. This is our expression tree, and I just was watching our video, and I realized we forgot a huge problem. We've created a huge problem. We have a big memory leak in our expression tree. So let's go ahead and fix that. If we jump back up into our destructor, what we need to do is we need to add the deletion of all the nodes that we've just spent a bunch of time creating in our binary tree. So let's go ahead and write that code real quick. So the first thing we want to do is, we're going to create a recursive function. We're going to call this helper function delete tree. We're going to pass in the root node. Okay, so now we have this void delete tree. We're going to create a new expression tree node pointer. And this is the pointer that we want to delete. Well, we want to first check to see if this node is null. If node equals null, hey, perfect, we're done. Don't execute any more code in this function. If it's not null, then you know what we want to do? We want to traverse the tree. And we want to go down the left side and the right side and then delete node. So what we're doing here is we are starting at that root node. And we're going to say, hey, if you have children, basically, if you have a left, delete your left. So we're not actually checking null. That's what's going to be checked here. So we call in. So let's say we have 1 plus 2 tree, or what the 1 plus 2 expression. That means our tree is going to have a plus as the root node, and the left is the 1 operand, and the right is the 2 operand. So it's going to call delete plus. All right, and then that delete plus is going to call delete left. That delete left is going to call delete left again. Well, at that point, we're on the 1 node. Oh, sorry. At that point, that node is null. So then we jump back up to the 1. And then we say delete right. Okay, well, the right is null as well, based on this function. So we return from the function. And so now we've called delete left and delete right on that 1 node. So now what we want to do is we want to delete itself. So the 1 node is now deleted from memory. This code will return, and then we'll jump back up to the plus operator. And so the plus, we stopped on this left because we traversed down the left side of the tree. Now on the right, we're going to traverse down the right side of the tree, obviously. So we're going to jump down to that 2 operand, and then we're going to do the same check. Hey, 2, that node is not null, so we want to delete left. So we call delete tree left again. And now we have the left of the 2 node, which is null, so we return. And now we jump back up into the 2 node, and so it stopped executing on this line. And now it calls the right. 2 right is null, it returns out. And then we continue executing, and it deletes the node. Then we jump back up to the plus node. Well, the last line it executed here was right. So now we delete itself, delete node, all is good. And then at the end of this, since the node that the root is now pointing to is an invalid pointer, and so we don't want a dangling pointer, we'll set root equal to null. Okay, I forgot about that when I was talking and going through the explanation of the end of this course. I saw that and noticed it and didn't want to leave that unfinished. So here's kind of a little bonus video. You'll have 6 videos this week. All right, thanks.